9.8. In this lecture video, I'm going to show you something called the compound inequalities. All right, and in this particular video, in 9.8, I'm going to show you how to solve compound inequality containing the word and. All right, so what's a compound inequality? Compound inequality are two inequality, okay, that are related by the word and, the word or. All right, so basically the solution, okay, that we get after solving the inequality, solving the two inequalities, okay, are related by the word and, the word or. So for the word or, the union, okay, so let's read right here. The word or is used to indicate union. So the union symbolize the later, symbolize this thing look like a U of two or more sets is the set of all elements that belong to either one set or the other set or both sets. Okay, so what does that mean really? Okay, so let's say here I have a set and here I have another set. Okay, let's just call this 1, 2, 3, 4, 5. Okay, so let's say pick the number 2. Okay, pick the number 2 using the word or. 2 is in this set or it can be in this set. Okay, as long as my solution 2 or the number 2 I'm picking is in one or the other one, then that is actually how we use the word or. Okay, the word intersection, okay, the word intersection using this symbol of two or more set is the set of all elements that belong to both of them. So this got to be belong to both of them. So tell me, out of the 5 number I wrote, which number belong to both of them? Got to be the 3, because the 3 is the intersection between the what? Between the two sets. Okay, all the other numbers are either belong to one set or belong to the other set, but the 3 is belong to both of them. So that's why it belong to this set on the left and belong to the set on the right. Okay, so that's a very quick brief explanation of the word union and intersection. So in this video I'm gonna show you how to solve linear inequality with the word and. All right, so basically I'm solving two linear inequality at the same time. Once I finish solving it, then I'm gonna relate my solution using the word and. So this is a set of all x's such that 2x plus 5 is greater than 5. So let's solve for x first. 2x plus 5 greater than 5. And I got another equation is negative 23 less than equal to negative 3x plus 4. Okay, so let's solve for x for each inequality. Let me move the 5 over. That's 2x greater than 0, because positive 5 move over become negative. Divide both sides by 2, x is greater than 0. And, right, this variable term is negative, so I'm going to move it over here. Move the negative 23 back. So that's 3x. The inequality does not change when I move terms. The right side 4 still 4. Negative 23 come over become positive. That's positive 27 once I add them. Divide both sides by 3. X is less than equal to 9. So how do I relate the solution using the word and? Okay, this is the way we read it. This is the way we read it. I'm looking for a number that is greater than 0 and it has to be less than or equal to 9. Okay, look at number line. Give me a number, or my solutions are greater than 0. Greater than 0 means to the right hand side of 0, right? So 0 is right here, go to the right side of 0. And based on my inequality without the equal sign, I'm using parentheses. Okay. Now, let's look at the other solution. I'm looking for numbers that are less than or equal to 9. So let's say 9 is right here. Less than equal to 9 is to the left side of 9. Let me use a blue, excuse me. Let me use a blue, okay? I'm going to use a blue. That will be going this way, right? So, with the equal to, I use a bracket, okay? I use a bracket. So, tell me. Give me a number that got to be bigger than 0 and it got to be less than 9. So that got to be anything between 0 to 9. So when I use a blue and I overlap with my yellow, it gives me the green part right here. So this green part is where my solution are related by the word and. So my interval notation got to be left to right, starting from 0 all the way to 9 using brackets. Okay. All right. Let's try another one. Okay. All right. Two different inequality: negative 4x less than 36 and x plus 9 less than or equal to 9. So this time I'm just going to simply divide both sides by negative 4 on both sides. Okay. So that will be x what? What happened to my inequality? When I divide it by negative coefficient, it got to flip. X is greater than 9, negative 9, and with the positive 5 over, that's x is less than or equal to 4. All right, so I'm looking for a number, or I'm looking for my answer that are bigger than negative 9. So that will be from negative 9, using parentheses, everything to the right. Let's use yellow. And my answer also need to be less than or equal to 4. So that will be at 4 going to the left. So I'm gonna use a blue. So lesser than equal to 4 is from 4 keep on going to the left. Okay, so my overlapping part where it's green is where my solutions are, because that solution, anything between negative 9 to 4, okay, is actually satisfying both inequality using the word and. So my answer got to be bigger than negative 9, and it also got to be what? Lesser than 4. So that will be anything between negative 9 to 4 using bracket on the 4. All right. Now, this is sometimes I call this the three-part inequality. So basically, let me write this. Basically, the variables is here in the middle, okay? So basically, this problem is saying negative 3 over 2x minus 3, right here, is greater than equal to negative 15. Now, look on the other side. The same negative 3 over 2x minus 3 is less than equal to 0. Remember, reading from the variable, that will be greater than equal to negative 15. So I'm actually solving both equations at the same time. And that's how it's actually related to the word and. Because my answer, I'm solving basically same equation, okay? Two separate equations at the same time. They just have a different numerical number on other side of inequality. So my solution, whatever this x going to be, is going to be bound by its inequality. Okay, so check this out. Okay, I'm just going to solve it from right here. So this is about the only time I will say, okay, to get x by itself, I need to plus 3 on all three sides. So negative 3 over 2x is the middle, right? Less than equal to 0 plus 3 is 3. Greater than equal to negative 12. All right, to get x by itself, I will divide all three terms by negative 3 half. So my inequality just all of a sudden switched. So x equals negative 12. Let's use our calculator. Oh, goodness, what's my calculator? Wait. Negative 12 divided by parenthesis negative 3 over 2. That will give me 8 right here. 3 divided by negative 3 half. Divided by negative 3 over 2. That's negative 2. Alright, so this x is actually bound by these two sides. So I'm looking for a number that got to be bigger than or equal to negative 2. Also got to be less than or equal to 8. Okay, let's do this part first. Greater than or equal to negative 2, that's for negative 2 to the right. The other one, x got to be less than 8. X got to be less than or equal to 8. Oh, I'm sorry, I was supposed to use a bracket earlier. Sorry, that's a bracket. X is less than or equal to 8. That would be from 8 going to the left. So by having the variable x in the middle on the graph is actually related to the word and, because now I'm basically looking for a number or numbers bigger than or equal to negative 2 and also what? Less than 8. So that will be everything between negative 2 all the way to 8 are my solutions, because I got infinite number of answers just in between those two numbers. Okay, so this three-part inequality related to the word and. All right, so that will conclude this lecture video, solving linear inequality related by the word and. All right, thank you for watching.